Welcome to the Antonio Zamora podcast that discusses a variety of scientific topics. The Tunguska event was a massive series of explosions in Siberia, Russia, on the morning of June 30, 1908. The explosions are attributed to the airburst of a stony meteoroid about 100 meters or 330 feet in size. The meteoroid is thought to have disintegrated at an altitude of 5 to 10 kilometers above the surface of the Earth. In 1921, the Russian mineralogist Leonid Kulik led a team of scientists to the Tunguska River basin to conduct a survey for the Soviet Academy of Sciences, but they were not able to visit the central blast area. However, from many local accounts of the event, Kulik believed that the explosion had been caused by a giant meteorite impact. A second scientific expedition in 1927 found that there was no crater at ground zero. Instead, they found a zone roughly 8 kilometers across where the trees were scorched and without branches, but still standing upright. Trees more distant from the center had been partly scorched and knocked down in a direction away from the center, creating a large radial pattern of downed trees in an area of 50 by 70 kilometers. Kulik found several pothole bogs that he thought were meteorite craters, but at that time he did not have the means to excavate them. During the next 10 years, Kulik led 3 more expeditions to the area, and after laboriously draining a bog with a diameter of 32 meters, he found an old tree stump at the bottom, ruling out the possibility that it was a meteorite crater. Eyewitness testimonies of the Tunguska event provide important information that cannot be obtained by just examining the geology of the terrain and the orientation of the falling trees. This is a testimony of Chushan of the Shanghai tribe, as recorded by I.M. Suslov in 1926. We had a hut by the river with my brother Chekarin. We were sleeping. Suddenly, we both woke up at the same time. Somebody shoved us. We heard whistling and felt strong wind. Chekarin said, "Can you hear all those birds flying overhead?" We were both in the hut, couldn't see what was going on outside. Suddenly, I got shoved again, this time so hard I fell into the fire. I got scared. Chekarin got scared too. We started crying for our father, mother, brother, but no one answered. There was noise beyond the hut. We could hear trees falling down. Chekarin and I got out of our sleeping bags and wanted to run out, but then the thunder struck. This was the first thunder. The earth began to move and rock, the wind hit our hut and knocked it over. My body was pushed down by sticks of the hut, but my head was in the clear. Then I saw a wonder. Trees were falling, the branches were on fire. It became mighty bright. How can I say this? As if there was a second sun. My eyes were hurting. I even closed them. It was like what the Russians call lightning. And immediately there was a loud thunderclap. This was the second thunder. The morning was sunny. There were no clouds. Our sun was shining brightly as usual. And suddenly there came a second one. Chekarin and I had some difficulty getting out from under the remains of our hut. Then we saw that above, but in a different place, there was another flash, and a loud thunder came. This was the third thunder strike. Wind came again, knocked us off our feet, and struck the fallen trees. We looked at the fallen trees, watched the treetops get snapped off, and watched the fires. Suddenly, Chekarin yelled, "Look up!" and pointed with his hand. I looked there and saw another flash, and it made another thunder, but the noise was less than before. This was the fourth strike, like normal thunder. Now I remember well, there was also one more thunder strike, but it was small and somewhere far away where the sun goes to sleep. It is important to note that this testimony mentions 5 explosions. They were associated with a flash and strong ground tremors followed by the sound of an explosion. Another eyewitness testimony reporting multiple explosions was printed on the Krasnoyarsk newspaper about 2 weeks after the Tunguska event. Notice that the dates are different because Russia was still using the Julian calendar and did not adopt the Gregorian calendar until February 14, 1918. The report says that on the 17th, an unusual atmospheric event was observed. At 7:43, the noise akin to the strong wind was heard. Immediately afterward, a horrific thump sounded, followed by an earthquake that literally shook the building as if it were hit by a large log or a heavy rock. The first thump was followed by a second, and then a third. Then the interval between the first and the third thumps was accompanied by an unusual underground rattle, similar to a railway upon which dozens of trains are traveling at the same time. Afterward, for 5 to 6 minutes, an exact likeness of artillery fire was heard, 50 to 60 salvos in short, equal intervals, which got progressively weaker. About 1.5 to 2 minutes after one of the barrages, 6 more thumps were heard, like cannon firing, but individual, loud, and accompanied by tremors. The sky at the first sight appeared to be clear. There was no wind and no clouds. Upon closer inspection to the north, where most of the thumps were heard, a kind of an ashen cloud was seen near the horizon, which kept getting smaller and more transparent, and possibly by around 2 to 3 p.m. completely disappeared. In a video interview, Mark Boslow, who is a physicist at Sandia National Laboratories, compares the Chelyabinsk meteor, which exploded over Russia on February 15, 2013, to the Tunguska event. Boslow says that the energy of the Chelyabinsk meteor was spread out over a long distance because it came at a shallow angle. By the time the meteor got to the ground, it was fairly weak and the explosion was not strong enough to kill people. Boslow believes that the Tunguska meteor sped toward the Earth at a far more vertical angle. According to Boslow, a meteor coming at a more vertical angle dissipates all its energy in a much shorter span of distance, and it also descends at a much lower altitude before its final terminal explosion, and so more of that blast wave energy comes to the ground. So if you are directly beneath it, you are going to feel a much stronger impact. In order to understand airbursts, we have to be familiar with the chemistry and physics of explosions. The chemical explosion of TNT, for example, produces gases and atomic carbon. Such chemical reactions are not expected in a meteor airburst. Meteor explosions are caused by the thermal expansion of volatile compounds within the matrix of the meteor until the internal pressure exceeds the yield strength of the meteor. Iron meteors do not explode during their passage through the atmosphere. Atmospheric friction hits the iron and burns its exterior. If the meteor is large enough to avoid burning up in the atmosphere, it will strike the surface of the Earth. The kinetic energy of the impact will generate heat and produce an explosion that will vaporize the projectile and the target, similar to the impact that created Meteor Crater in Arizona. The ice boulders that made the Carolina Bays did not explode during their re-entry through the atmosphere. Ice is a poor conductor of heat, and atmospheric friction will vaporize the surface, but it will not hit the interior to cause the ice boulder to explode. Stony meteorites and comet fragments are the extraterrestrial objects most likely to explode during their passage through the Earth's atmosphere. These objects have mixtures of minerals and frozen gases that are unstable when heated. When the matrix of the meteor is heated to 1900 degrees Celsius during atmospheric re-entry, the volatile components trapped within the matrix expand and build pressure until they exceed the yield strength of the meteor in a great explosion. A paper published in 2013 examined samples from peat bogs in Tunguska and found minerals associated with hypervelocity meteorite impacts. Lonsdaleite is a diamond with hexagonal lattice. Troilite is a rare iron sulfide mineral associated with meteorites. Taenite is an alloy of iron and nickel found mostly in iron meteorites. Gamma iron is a metallic non-magnetic form of iron also called austenite. Schreibersite is an iron-nickel phosphide mineral common in iron-nickel meteorites. The paper concluded that the Tunguska event was caused by a meteoritic explosion. The eyewitness descriptions of the Tunguska event clearly state that there were multiple explosions and tremors. This can be explained if a single meteorite broke up into multiple pieces by aerodynamic friction when it entered the atmosphere. But in this case, the impacts and explosions would all have happened within a few seconds of each other. However, the eyewitnesses reported intervals of several minutes between the explosions. This means that the meteor was already fragmented when it approached the Earth and multiple pieces entered the atmosphere at slightly different times. Based on the reports that there were explosions about 2 minutes apart, the model for the Tunguska event needs to consider that 2 or more pieces of a meteor impacted the Earth. At the typical speed of 18 kilometers per second for asteroids, the distance between the 2 pieces was about 2,000 kilometers. The rotation of the Earth and its orbital speed around the Sun need to be taken into consideration to calculate the trajectory of the asteroid pieces toward the Tunguska area. Some scientists have suggested that the Tunguska event was caused by impacts of comet debris from the Beta Taurid shower, which is one of the 2 annual appearances of the broad meteor stream associated with Comet Encke. Those impacts would have hit the Earth at about 31 kilometers per second. If the comet pieces had a speed of 31 kilometers per second, the distance between the pieces would have been 3,720 kilometers in order for them to strike the Earth with an interval of 2 minutes. The Chelyabinsk meteoroid explosion sent a shower of pieces under the explosion area. One large piece landed in a lake, and many small pieces fell in the deep snow, creating penetration funnels as illustrated here. Something similar would have happened in the Tunguska explosion, but the small pieces would have been lost in the bogs. Russian scientists have conducted many studies trying to determine the epicenter of the Tunguska airburst. The Russian Wikipedia page lists the coordinates obtained by studies based on the radial orientation of the falling trees, on the physical parameters of the explosion, on the asymmetry of the fallen trees, and on the burn injuries of the trees. The results point to different locations. This image shows pushpins at the different locations of the Tunguska epicenter reported by researchers. There is not much agreement. The Russian Wikipedia page lists the main coordinates of the Tunguska event in the center of a circular feature, but the circular feature is not a crater. It is a hill that is 80 meters higher than the surrounding treeless areas. The Tunguska site has numerous bogs of different shapes and sizes. The bogs are notable because no trees grow on them. Some of the large bogs were given names by Leonid Kulik, who studied the Tunguska site for many years. In 2007, scientists from the University of Bologna in Italy identified Lake Cecco in the Tunguska region as a possible impact crater from the event. The scientists studied the funnel-like bottom of the lake and the sedimentary deposits and concluded that Lake Cecco may have formed due to a secondary impact into alluvial swampy ground. Lake Cecco is approximately 8 kilometers from the epicenter of the Tunguska event. The Italian scientists provided graphs of seismic reflections that documented the main features of Lake Cecco, and they created an image of the proposed secondary impact crater. The images do not show any uplifted rims that typically characterize impact craters. In 2017, new research by Russian scientists rejected the theory that Lake Cecco was created by the Tunguska event. Using soil samples, they determined that the lake has existed for more than 280 years, which makes it much older than the Tunguska event. The Tunguska pit bogs may be the result of blowouts from extraterrestrial airbursts, but they are not Carolina bays. The Tunguska bogs are not uniform in shape, they do not have elliptical geometry, they do not have a common orientation, and they do not have raised rims. The features in Tunguska are definitely not Carolina bays. The Carolina bays are the remodeled remains of oblique conical craters formed on viscous ground by secondary impacts of glacier ice boulders ejected by an extraterrestrial impact on the Laurentide ice sheet in the Great Lakes region. The Carolina bays have elliptical geometry, common orientation toward the Great Lakes, and raised rims typical of impact cratering. Do not let anybody tell you that the Tunguska pit bogs are just like the Carolina bays. No way, not even close. Thank you for listening to this podcast. Please visit the YouTube channel or the website for many other interesting topics.